In observational astronomy, a double star is a pair of stars that appear close to each other in the sky as seen from Earth when viewed through an optical telescope. This can happen either because the pair forms a binary star, i.e. a binary system of stars in mutual orbit gravitationally bound to each other, or because it is an optical double, a chance alignment of two stars in the sky that lie at different distances. Binary stars are important to stellar astronomers as knowledge of the motions allows direct calculation of stellar mass and other stellar parameters. Since the beginning of the 1780s, both professional and amateur double-star observers have telescopically measured the distances and angles between double stars to determine the relative motions of the pairs. If the relative motion of a pair determines a curved arc of an orbit, or if the relative motion is small compared to the common proper motion of both stars, it may be concluded that the pair is in mutual orbit as a binary star. Otherwise, the pair is optical. Multiple stars are also studied in this way, although the dynamics of multiple stellar systems are more complex than those of binary stars. There are three types of paired stars. Optical doubles are unrelated stars that appear close together through chance alignment with Earth. Visual doubles of stars whose binary status was deduced through more esoteric means, such as occultation, spectroscopy, or anomalies in proper motion. Visual binaries are gravitationally bound stars that are separately visible with a telescope. Conceptually, there is no difference between the two visual categories, and improvements in telescopes can shift previously double stars into visual binaries, as happened with Polaris in 2006. Thus it is only the inability to telescopically observe or detect orbital motion in the visual double stars that differentiates these two groups. History. Mizar in Ursa Major was observed to be double by Giovanni Battista Riccioli in 1650. The identification of other doubles soon followed. Robert Hooke discovered one of the first double-star systems, Gamma Arietis, in 1664, while the bright southern star Crux, in the Southern Cross, was discovered to be double by Fontenay in 1685. Since that time, the search has been carried out thoroughly and the entire sky has been examined for double stars down to a limiting apparent magnitude of about 9.0. At least 1 in 18 stars brighter than 9.0 magnitude in the northern half of the sky are known to be double stars visible with a 36-inch telescope. The unrelated categories of optical doubles and true binaries are lumped together for historical and practical reasons. When Mizar was found to be a binary, it was quite difficult to determine whether a double star was a binary system or only an optical double. Improved telescopes, spectroscopy, and photography are the basic tools used to make the distinction. After it was determined to be a visual binary, Mizar's components were found to be spectroscopic binaries themselves. Observation of double stars. Visual double stars are defined as double stars which are visible in an optical telescope. This is the majority of all known double stars. If visual doubles show similar properties, such as similar proper motion through space, trigonometric parallaxes, or radial velocities, this is evidence that they are gravitationally attached and form a binary system. In this case, the visual double star is called the visual binary. Observation of visual double stars by visual measurement will yield the separation, or angular distance, between the two component stars in the sky and the position angle. The position angle specifies the direction in which the stars are separated and is defined as the bearing from the brighter component to the fainter, where north is 0 degrees. These measurements are called measures. In the measures of a visual binary, the position angle will change progressively and the separation between the two stars will oscillate between maximum and minimum values. Plotting the measures in the plane will produce an ellipse. This is the apparent orbit, the projection of the orbit of the two stars onto the celestial sphere. The true orbit can be computed from it, although it is expected that the majority of catalogued visual doubles are visual binaries. Orbits have been computed for only a few thousand of the over 100,000 known visual double stars. Distinction between binary stars and other double stars. Visual double stars may be distinguished from binary stars by observing the relative motion, if the motion is part of an orbit, or if the stars have similar radial velocities and the difference in the proper motions is small compared to the common proper motion. The pair is probably physical, when observed over a short period of time. The components of both optical doubles and long-period visual binaries will appear to be moving in straight lines. For this reason, it can be difficult to distinguish between these two possibilities. Designations. Some bright visual double stars have a Bayer designation. In this case, the components may be denoted by superscripts. An example of this is Alpha Crucis, whose components are Alpha 1 Crucis and Alpha 2 Crucis. Since Alpha 1 Crucis is a spectroscopic binary, this is actually a multiple star. Superscripts are also used to distinguish more distant, physically unrelated pairs of stars with the same Bayer designation, such as Alpha 1, 2 Capricorni, Xi 1, 2 Centauri, and Xi 1, 2 Sagittarii. These optical pairs are resolvable by the naked eye. Apart from these pairs, the components of a double star are generally denoted by the letters A and B appended to the designation of whatever sort of the double star. For example, the components of Alpha Canis Majoris are Alpha Canis Majoris A and Alpha Canis Majoris B. The components of 44 Bootis are 44 Bootis A and 44 Bootis B. The components of AD 16402 are ADS 16402A and ADS 16402B, and so on. The letters AB may be used together to designate the pair. In the case of multiple stars, the letters C, D, and so on may be used to denote additional components, often in order of increasing separation from the brightest star, A. Visual doubles are also designated by an abbreviation for the name of the discoverer followed by a catalogue number unique to that observer. For example, the pair Alpha Centauri AB was discovered by Father Richaud in 1689, and so is designated DAR HD1. Other examples include Delta 65, the 65th double discovered by James Dunlop, and Sigma 2451, discovered by FGW. Struve. The Washington Double Star Catalogue, a large database of double and multiple stars, contains over 100,000 entries, each of which gives measures for the separation of two components. Each double star forms one entry in the catalogue. Multiple stars with n components will be represented by entries in the catalogue for n-1 pairs, each giving the separation of one component of the multiple star from another. Codes such as AC are used to denote which components are being measured, in this case, component C relative to component A. This may be altered to a form such as ABD to indicate the separation of a component from a close pair of components. Codes such as AA may also be used to denote a component which is being measured relative to another component, A in this case. Discoverer designations are also listed. However, traditional discoverer abbreviations such as Delta and Sigma have been encoded into a string of uppercase Roman letters, so that, for example, Delta 65 has become DUN 65 and Sigma 2451 has become SDF 2451. Further examples of this are shown in the table to the right. Examples: visual binaries are crux. Alpha Centauri, Capella, Eridani, Polaris, Procyon, Sirius, optical doubles Alpha 1 and Alpha 2 Capricorni, Theta Musca and Theta Musca b Eta 1 and Eta 2 Coronae Australis, Kappa 1 and Kappa 2 Coronae Australis, Winnaker 4, uncertain Alpha Centauri system and Proxima Centauri. Association is generally considered a physically connected system. Castor system and YY Geminorum is generally considered a physical system. Mizar system and Alka